Hi, I'm going to have a look at how to get started with STM32 development on Linux to move away from development boards like the ESP32 and the Raspberry Pi Pico. The reason being is that STM32 chips have flash locks and the ability to easily make custom bootloaders, which are things that are needed if you seek to develop a project into a product. We're going to go about getting the things we need to get up and running. If we go over to the STM website and go over to downloads, there's some tools that we need. So there is a separate program for the configuration of the chip, STM32 MX. Now this program will help you create boilerplate code and configure your chip as you want it. Follow the installation prompts and then set up a project. The program has a GUI to help us set up the clock. This here is the repo of the development board that I got, a STM32G0B1CBT6. In the hardware we have a schematic, and by looking at the schematic we can set up the project as desired. This repo also has an example project that I can clone and then use to base a new project off of. So I'm just going to git clone this, and I'm going to make a simple hello world blinking LED. Conveniently, there is a surface mount LED on this board, so I'll just be using that. So if I open up this cloned project, and what I'm going to do is go File, Save Project As, Save, and then I'm going to edit these pins. If we look at the schematic, we see that the LED is on pin PC6. So in the configurator, PC6, and we go GPIO output. And I'm just going to remove some of these. Here's the clock correctly set up. And then we go to Project Manager. And here we can select the type of project we want to generate. So you've got a choice of some IDEs. I'm going to select a CMake project, and then I go generate code, and it's going to generate boilerplate code that we then add some logic to. We now have some boilerplate code. The main file is in core source, and then we have a main.c. Boilerplate code has lots of comments to give you hints where to put the codes. The boilerplate code has got HAL, hardware abstraction layer, functions for all of the peripherals. So doing a simple grep on HAL GPIO, I can see the toggle pin function here, as well as a HAL delay. Again, over on the STM website we can find documentation for all of the HAL functions. So this document here is for the chip series that I'm using, the STM32G0. So for example, here's the documentation for the I2C bus. Right, now we've got some boilerplate code, we actually have to compile it. So if we go over to ARM's website, we need ARM's compiler, developer.arm.com downloads. We have the ARM GNU toolchain. I need this table, GCC ARM, for Linux. So with it downloaded, let's extract it. In the download we have pre-built blobs, so we don't need to compile it. The next thing to do is to add it to your path so that we can actually use these binary files. So I have moved the directory and I have added it to my path in my bash rc file. Here we go. GCC version. Yeah, there we go. So now let's go and make this project. There is a GCC ARM none EABI CMake file, and this CMake file will be using the ARM compiler that we just added to the path. When we call CMake, we just have to specify the location of this CMake file, the CMake toolchain file, and then the path. So now we call make, and our project has been compiled, and I now have a led.elf file. So now we've compiled the project, we need to actually load it onto the chip, and we can do that easily with this programmer, which is an ST-Link, which you can get for a few dollars. To actually be able to use this programmer, we're going to need a program to interact with it. Here is the repo for ST-Link, which has a series of programs that we can use to interact with STM32 chips, such as ST-Flash, ST-Info, to get information on the chip. So do a git clone. And then we just need to build it. So and there we have our binaries compiled. And then if you want them in your file path, you will have to do sudo make install. And then if we look at the Flash tool, we can do a read, we can do a write, a raise, and a reset. So we need to do flash, write, file, address, and size. One thing we need to bear in mind is that this ST-Flash tool will not work with an ELF file. So we will have to convert this ELF file into a binary file. One of the ARM binaries that we added to our path will allow us to do that. ARM none EABI object copy. Specify the object type, binary, provide the input file, provide the output file. There we've generated a binary file. So now we can flash this binary file onto the STM32 chip. So plug it in and flash it. So st flash write led bin, and then input the address. And the address we need is in hex 8 million. Bum, 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 bum. And it's blinking away. In conclusion, STM32 chips are an impressive platform to develop on, and the tooling works seamlessly on Linux.